Okay, so let's look at our Explore 4. So after reading the question, we can find n congruent to 1 if I mod 3. N congruent to 3 if I mod 7. And n congruent to 8 if I mod 11. I want to find out the largest 3-digit number. Of course, I want to find out largest one. So maybe we can start from here. Okay? Start from equation 1, equation 2, and equation 3. We need to meet these 3 conditions. We start from here. So what is the largest number? Then divide by 11, the remainder is 8. We can find maybe 990. Yes, I can exactly divide by 11. So if I want to keep the remainder is 8. Of course, the first one is 998. Okay, 998. And after that, minus 11, 978. After that, minus 11, 967. Okay? Sorry, I calculated wrong. So it's minus 11, 987. Then minus 11, 976. And minus 11, 965. Okay, we just list here. So this is the condition. We divide by 11. The remainder is 8. Okay, so the next step. Okay, so the next step, we need to meet the requirement 2. So from here's number. So we just try. Okay, so 998 divided by 7. What's the remainder? 998 divided by 7. You can find it's 1. 29 divided by 7. 4. Yes. 18 divided by 7. 2. Remainder 4. So pass. And 987 divided by 7 is 1 and 4 and 1 pass because remainder 0. So 976 divided by 7 is 1. 27 divided by 7 3. 66 divided by 7 9. Remainder 3. Okay, yes, I can find out now the list, the smallest, the biggest number can meet this requirement is 976. So we start from 976, and each time I minus what? I minus 77, right? I minus 77, it will become 899. Then I minus 77 and continue. Because this number is meet the requirement 3 and 2. So let's try. Who divide by 3? The remainder is 1. 976 divided by 3. What's the remainder? It's 3. Divided by 3. What's the remainder? 3, 2, 5. Remainder 1. Yes. I try one time. I just find out the answer. 976. So the answer is 976. Okay, so now let's continue to look at the next one. For a natural number is greater than 10. And 1 divided by 5, there's remainder 1. So that means n congruent to 1 if I mod 5. And n is congruent to 2 if I mod 7. And n is congruent to 3 if I mod 9. So there is a very interesting thing. If you compare 1, 2, 3, there are 3 consecutive numbers. 5, 7, 9. Okay, their difference is also what? Not consecutive, but the difference is a constant value, which is 2. So that means what? So this one, I cannot have the same difference, but 2n congruent to 2, 2n congruent to 4, and 2n congruent to 6 if I mod 5, mod 7, and mod 9. So this time you can find 2 and 5, the difference is 3. 4 and 7, the difference is 3. And 6 and 9, the difference is 3. So that means we have the same difference. Since we have the same difference, so that means I can every time plus 3. So you can see 2n congruent to 2 plus 3, 2n, we plus 3 on both sides, congruent to 4 plus 3, and 3 plus 2n equals to 6 plus 3. If I mod 5, I mod 7, and I mod 9. Okay, so these are the 3 things I can find. So this time 2 plus 3 equals to 5. 5 mod 5 actually is 0. 4 plus 3 equals to 7. 7 mod 7, 0. 6 plus 3 mod 9. 9 mod 9, 0. Okay, so that means 2n plus 3 must be the multiple of the LCM of 5, 7, and 9. Okay, so that means 2n plus 3 equals to what? The LCM of 5, 7, and 9. 5 times 7 times 9 equals to 315. So that means 2n equals to 312. And what is the smallest value? It should be 156. So the smallest natural number that satisfies these conditions will be 156. Okay? So now let's look at our challenge. So the challenge, I think the best way is to use the congruent equation. So n congruent to 7, n plus 1 congruent to 11, n plus 2 congruent to 13, right? Congruent to 13. If I mod 7, I mod 11, I mod 13. Okay, so this time I can change to what? I can change to n congruent to 5 if I mod 7, n congruent to 10 if I mod 11, and n congruent to 11 if I mod 13. So this time, can you find any pattern here? Do we have the same difference or something else? No. So that means I have to do it step by step. Okay, I need to use the method satisfy the satisfy the conditions step by step. So I know there are 3 consecutive numbers, right? So let's try to find out them together. So firstly, yes, what should I do? So maybe we just start from the first one. Okay, we just from the first one. We know. Oh, sorry, this one we don't need to minus 2. Sorry. So this is congruent to 0. So for the condition 1, it should be n equals to 7k. So let's take the place to equation 2. 7k congruent to 10 if I mod 11. So 7k congruent to what? This time I want to be the multiple of 10. So of course 10 plus 11 mod 11. So 7k congruent to 21 if I mod 11. So k congruent to 3 if I mod 11. So I can see k's general form is k equals to 11m plus 3. Let's take the place of 11m plus 3 into this n. So I can see n equals to 7 times 11m plus 3 equals to 77m plus 21. 77m plus 21. So now let's take the place into condition 3. Let's take the place to condition 3. So it will become 77m plus 21 congruent to 11 if I mod 13. So yeah, let's try to separate them. 77m, right? So it should become what? You divide by 13, you can find it should be 65m plus 12m plus this one 21 divided by 13. What's that? So it should be congruent to 7 plus 1, 8. Congruent to 11, right? Congruent to 11 if I mod 13. So 12m congruent to 3 if I mod 13. So this one, yeah, you just plus and to have a try, you can find 3. Actually, I need to plus 117. So 12m is congruent to 120 if I mod 13. So m congruent to 10 if I mod 13. Okay, so what is the minimum number of m? M minimum equals to 10. So what is the value of this n? N equals to, you take the place to this place. 77 times 10 plus 21 equals to 791. So the smallest number n equals to 791. So what's the 3 consecutive number? 791, 792, and 793. Okay, so this is our congruent equation. So seems very difficult, but you are very familiar with that. You practice more, so it will be a very easy question.